let's look at the technique called integration by parts. Okay, so the formula we get in the formula booklet, and it looks like this. It says the integral of u dv by dx with respect to x is equal to uv minus the integral of v du by dx with respect to x. Best way for us to think about this is if we just do a couple of examples. Okay, really important that when you're doing integration by parts, you've got to think about what are we going to let u equal. And the little way that I remember this is by remembering late. So if there's a logarithm, that's what we're going to let equal to u. If there's some algebra, that's what we're going to let equal to u. And the order that we go down is the order of precedence. So obviously if there's a log, that's always going to be u. If there isn't a log, but then there's algebra, that would be what would let equal to u. Okay. So why would we use integration by parts? Let's think about a couple of integrals. If I said integrate x sine 2x, or integrate x to the 4 ln x, or integrate x squared e to the 3x. First thing we've got to realise, it's a bit like the product rule. This, like, you know, when you have to differentiate something, if there's two functions times together, it'll just say differentiate. You have to realise that you're using the product rule. Like, if I was asked to integrate this, we'd have to realise that, oh, we've got two functions multiplied together. So I can't just integrate it as one big thing. Like, I can't integrate x and integrate sine. That does not work. We have to look at this and realise that it's going to be an integration by parts question. So what we're doing when we start integration by parts, this integral is actually at the left hand side of our formula. So part of it we're going to call u, and part of it we're going to call dv by dx. So in this situation, u would equal x and dv by dx would equal sine 2x. For this next one, again, we've got two things multiplied together. So you might think, oh, well, let's let u equal x to the 4, but you don't, because if you think about the late rule, if there's a logarithm, this here is going to be u, so u would equal ln x, and that means this path, dv by dx, would equal x to the 4, because we're calling one part u and we're calling one part dv. For the last one, we've got two functions multiplied together. Which one's going to be called u? Which one's going to be called dv? Well, we haven't got any logs, we have got algebra, so u is going to equal x squared, which means e to the 3x is going to be dv by dx. It's very important that you do this the right way around, because what we need to differentiate to figure out what du by dx is. So I'm going to differentiate this one. dv by dx, we need to figure out what v is. So we have to differentiate one of them, we have to integrate the other one. Okay, so let's try a couple of examples from the handout. Example 1 is the integral of x cos x. So obviously we have to do integration by parts. Like, we have got two functions of x which are being multiplied together. Okay, very important that we start this correctly. If you make a mistake at the beginning, the rest of the question is going to become a big problem. Okay, so we've got to first of all pick, well, what's going to be u? And there's no logs, algebra, so I'm going to say, well, u equals x. That means the other part, remember the left-hand side is our original question, is dv by dx. So dv by dx would equal cos x. Okay, be very careful now, guys. We are going to differentiate that one, but integrate the other one. The most common mistake that people make on this topic, when they get used to it, they just like sort of fall into a bit of a rhythm, but you've got to remember that you're integrating this one. You're not differentiating this one. Okay, so if we wanted to figure out this, du by dx would equal 1, and we're integrating. So don't forget, integrate anti-clockwise. So v would equal sine x. So now that we've got everything that we need, we now look at the right hand side of this. Okay, so the original question we couldn't integrate because we had two functions multiplied together. But we can say that, well, that original question we know is the same as this rearrangement. So we're going to use the rearrangement on the right hand side. So I'm going to say, well, that's equivalent to u times by v, which would be x sine x minus the integral. And you get this in the booklet, so you don't need to worry about it, but I mean, if you've done a few of these, you will remember it. The two new things that you've just found go inside. So we've got v, which is sine x, multiplied by du by dx, which is 1. And now if you notice, by using this rearrangement, we haven't got that problem anymore. Like, we haven't got two functions multiplied together. So two functions of x, we've just got a constant and a function of x. So this we can integrate. Okay, so we go the last step by actually integrating what we've got left inside. Integrate sine x, you get minus cos x, so that would be minus integral of sine, which is minus cos. So our final answer would be x sine x plus cos x plus c. Example 2 is the integral of x cubed ln x. And again, don't forget, we have to realise that we're using parts for this question. We've got two functions multiplied together. U equals dv by dx equals. So obviously, let's just let u equal x cubed, because it looks like u dv. No, don't do that. Okay. There's a log, so that ln x has to become u. Think about it a bit more deeply why we're doing this. Like, you want to, whatever you let equal u, you're going to differentiate. And we know how to differentiate logs. When we differentiate logs, we get fractions. 1 over x, derivative on top, function on the bottom. Okay, so we want, if there's a log involved, we want to be differentiating the log, because we can differentiate logs. That means dv by dx must equal x cubed. So remember, when we go this way, just make sure we integrate this way. Please don't forget that. So if we integrate x cubed, we'd get x to the 4 over 4. Okay, now let's use the right hand side, because we couldn't integrate this, but we can integrate the right hand side. So we've got uv, so this times by this, I'm going to write as a quarter x to the 4 ln x minus, inside the integral, the two new things. Okay, so it's v times by du. Now what we've got here is x to the 4 over 4 multiplied by 1 over x. Now you might think, oh, we've still got a problem, because you remember the whole point of this topic is we can't integrate when there's two functions multiplied together. And we've still got two functions multiplied together, but the good thing about this is they are both functions of x, algebraic functions, so we can tidy this up. X to the 4 divided by x is just x cubed, isn't it? So we've got a quarter x to the 4 ln x minus, if that's all divided by 4, I'm just going to take a quarter outside of the integral. It's very, very good practice to simplify integrals by taking multiples outside. Dividing everything by 4 is the same as times by a quarter. X to the 4 divided by x is just x cubed. So I'm going to integrate x cubed. And that would give me a quarter x to the 4 ln x minus a quarter. Integral of this would be x to the 4 over 4. Don't forget plus c. So tidying this up, we'd get a quarter x to the 4 ln x minus a 16th. Oops. A 16th x to the 4. You could obviously take a common factor out, you could take an x to the 4 out of both, you could take a quarter out of both. But for now, let's just leave it like that. Okay. Example 3 is 3x plus 1 multiplied by e to 2x minus 1. You've got two options of this. You could actually expand this out. If I expand the bracket, then I've just got an exponential which I can integrate, but I would have an x times by an exponential. So either way, we're still going to have to do integration by parts. I'm not going to expand it out. I'm just going to treat this as two functions multiplied together. Okay. So u equals dv by dx equals no logs. So algebra. So u would equal 3x plus 1. So that means du by dx would equal 3. dv by dx e to the 2x minus 1. Don't be one of those people that makes this mistake now. So many people, when I've been teaching this, make this mistake. You are integrating this, don't forget. Okay, so I'm integrating this. Integrating exponential, power stays the same. Should have given myself a bit more space there, shouldn't I? So that would be e to the 2x minus 1. And because we're integrating, remember you're dividing by the coefficients. So when we integrate, we divide by the 2. Okay. So let's see what we've got then. So u times by v, we're doing 3x plus 1 multiplied by this. This is all divided by 2, so I'm going to write it as, start with the number at the front, which is a half. 3x plus 1 needs to be in a bracket, because it's 2 terms. And then you're multiplying by e to the 2x minus 1. Minus, inside the integral v du, so that would be the two things we just found. Du is just 3, and that's being divided by 2. I'll tell you what, I'll do that in a second. So we're doing 3 times by a half e to the 2x minus 1. You should notice, by the way, when you get used to this, that you know you've done this correctly, because remember, we're trying to avoid having two functions multiplied together, and now what we've got is just a constant and a function. Okay, so we can integrate this. I'm going to take the 3 over 2 outside and just integrate e to the 2x minus 1. Integrate the exponential, power stays the same. Divide by the coefficients. Remember plus c, tidy it up, so we have 1 half 3x plus 1 e to the 2x minus 1 minus 3 over 4, remember multiply the tops, multiply the bottoms, e to the 2x minus 1 plus c. Okay. Final example that we're going to do on this video is integrate ln x. You might want to pause this and just have a little think about it for a second. Like, you might, it doesn't look like a parts question, does it? It definitely doesn't look like two functions multiplied together. And please do not write 1 over x. Okay, if we differentiate ln, we get 1 over x. If we integrate ln, we do not get that. Okay, so I haven't taught you how to integrate an ln yet. If we do want to think about it as a product of two functions, we just need to write it as the integral of 1 times ln x. And now we've got the two functions multiplied together. Okay, so u has got to equal ln x, which means dv by dx is just 1. So du by dx would be 1 over x. V integrate would be x. Plug into our formula. So u times by v, I'm going to write this as x ln x, remember, put the algebra at the front, minus the integral. Two things we just found. So v times by du, x times by 1 over x. It's just 1, isn't it? Okay, so we can get x ln x minus x plus c. Okay, hopefully that was useful. Try work through the exercise 1. Okay, and once you've worked through exercise 1, the next video we'll look at will be when we have to do integration by parts twice. Thanks guys.